Hello everyone. Today we're looking at the problem maximum amount of money robot can earn. This was question 2 in weekly contest 432. The question reads that we're given an m by n grid and a robot starts at the top left corner of the grid at 0, 0, and we want to reach the bottom right corner, which is m minus 1 and n minus 1. So the robot can move either right or down at any point. And each cell in this grid will contain a certain value. So if the coins is greater than or equal to 0, we will just gain that amount of coins. But if the coins is less than 0, then we are getting robbed. And what happens when we get robbed is that a robber will steal the absolute value of the coins in that cell. So if we hit a negative cell, we will lose that number of coins. However, we have the ability to neutralize robbers at most 2 times on the path. And when this happens, instead of losing those coins, nothing happens and it's just 0 change. So we want to return the maximum profit we can get on this route. So given the example 0, 1, negative 1, 1, negative 2, 3, and 2, negative 3, 4, our output would be 8. And the optimal path would be to start at 0, 0, and we get 0 total coins here because of the value. We move to 0, 1 and gain 1 coin because the value there is 1. Then we move to 1, 1, which is negative 2. However, we use our ability to neutralize here, so we actually don't lose any coins. Then we move to 1, 2, where we gain 3 coins. Then we move down to 2, 2, which is our ending, and we also get 4 coins there for a total of 8. So looking at this problem, you'll see there are several choices that we have to make, which is why it's a great fit for dynamic programming. So the choices are, as we're in each cell, we can either move right or down, right? So this is a very common grid traversal pattern for dynamic programming. This happens in a lot of problems where we have to choose a direction and see which the optimal path is. However, another thing is neutralizing, right? So we have the ability to neutralize any negative cell. So say we land on this negative 2. So we could neutralize it, right? We could say that we want to get rid of this, but what if we had, bigger negative numbers here? What if these were also negative, right? It might make more sense to not neutralize this one and then save our neutralizations for these later ones, because remember, we only have 2 of these. So there's really 2 types of choices we have to make: which direction to move, as well as which cells we're going to neutralize, if any. So once we realize this becomes just a very straightforward dynamic programming problem. So we're going to start at 0, 0, and then we can make a choice. Let's say here I have a value greater than or equal to 0, so here I will just gain whatever I have here. So let's say my current score is 0, right? And we're going to go on the optimal path. The optimal path here would be to go to 1, 1, but here we could also go down to this 1, 1, right? So we have either choice available. Let's try this path now. So here we're at 0, 1. Again, here is greater than 0, so we can just gain this. So our score becomes 1. Now from here, we have another choice. We can go to negative 1, or we can go to negative 2. Here, let's go down to negative 2. Here, we have another choice. We could say, I could either neutralize this, or I cannot neutralize this. It makes more sense to neutralize, so we gain 0, we go to 3, we gain that 3 to get 4, and then we go down to 4 to get 8 overall. So really, what we want to do is we want to try every single combination, and this example here would be an example of an optimal one. So to try out all these combinations, there are 3 things that our dynamic programming function has to keep track of. So first, the row, right? We have to know which row we're in. We have to know what column we're in. So this should be pretty straightforward. We just have to pass these along to our function so that we know what cell that we are at. Where we also are going to pass in, let's call this k here, right? And k is going to be the number of neutralizations that we have left. We want to keep track of this because we want to know that when we get to a negative cell, if we have any left or not. And there are different cases, right? We could get to this negative 2 with 2 neutralizations. We could get to it with 1 or 0. So we're going to have to keep track of all 3 of these so that we can try every single combination of our state and find the minimum one. So here we're going to have m, this is going to be n, and then this is going to be 2. So our time complexity here will be n times 2 for this entire problem. Let's look at the choices that we have to make at each step. So we could say if it's greater than or equal to 0, right? Our only choices are to move right or to move down, right? So this is our easier case. This is the case where we have a positive value, so all we need to decide is where to go next. The other case is where we're potentially going to lose points, right? So what we can do is move right and neutralize, or we can just move right and lose our points, right? So there are two possible things that we can do when we are going to lose points. We can either neutralize if we have the ability, or we can just choose to take the loss and move forward. The other options in this case are to move down and neutralize, or we can move down and just lose the points as well. So really we have two distinct cases that we have to handle. We have the good case, right, where we're just going to gain points, and here all we're going to do is choose which direction to go next and try out those possibilities. The other case is when we're going to lose points. So we have to both choose our direction, but also when we're choosing the direction, choose whether to neutralize this robber or to just choose to lose the point. And you'll see when we get into the code how exactly this is going to work. We're just going to try everything out. So just for convenience, I'm going to set up my n and m variables just to keep track of the row and column lengths. Then I have my recursive function here. And like we said, this is going to take in the row, the column, and how many neutralizations that we have left. So here's the case where we get to the end, right? We're at the end, we're at our target cell. So we have to decide here a certain case. So if we get here and it's negative, right, we could either decide to leave it and just, lose those points, or we can neutralize it. So really the optimal thing to do here is that if we get to the end and the value is negative and we have neutralizations left, we should just use that neutralization, right? Because we're not going to go anywhere else from here. If we have one left and the value is negative, we should just use it and return 0 from here. Otherwise, this will happen if either we are at a negative value but we don't neutralize, or if we're at a positive value. Otherwise, we just return that positive value. So a couple of cases here. I want to go over them again. Either we get to a negative value and we can neutralize, we return 0, or we get to a negative value and we can't neutralize, or it's a positive value, we're going to return that number of coins in that cell. Another edge case is where we go out of bounds. Here we just return negative infinity because this is not a valid case. Then we're going to handle our two distinct cases. So first we have here is where we're at a positive value. So this is the easy case, right? What we're going to do is just going to try out the different combinations, and we're going to take those coins. So we're going to say our answer becomes the maximum of our current answer, the coins plus going to the right, or the coins plus going down. The other case is where we have a negative value, right? And what happens here? So we have to check two things. If we can neutralize, then what we want to do is try neutralizing as well as not neutralizing. Because remember, it might be beneficial to take a hit now because there might be bigger negative values coming up later. So what we're going to do is say, my answer is the maximum of either moving to the right and losing that amount of coins, or moving down and losing that amount of coins, right? So here is the cases where we do not neutralize the robber. The other cases are where we do neutralize. So what we do is there's no change in our score. We're just going to move to the right and move down. But also notice that we decrease our neutralized value by 1 because we've used one of them up, so we have to decrement that value. This is the other case where we don't have any left. So in this case, we don't really have an option, right? We just have to lose the coins. So what we're going to do is say, my answer is the maximum of whatever answer I have, or going right and losing the coins, or going down and losing the coins. And this represents all the possibilities that we could do for each step. Then at the end, we're just going to return our answer from that recursive function. Then we're going to call it down here with 0, 0, and 2. And we're passing in these values because 0 represents the top row, 0 is the top column, and then we're going to start with 2 neutralizations for each test case. So this is why we pass in the 2. So let's submit and make sure that it works. And it does work. So hopefully this is helpful and it made sense. If you liked the video, please like and subscribe, and thank you for watching.